Good afternoon, grade 9 students, and welcome back to another bumper episode of Maths-Key Learning. So we are concluding the section of geometry on 2D shapes with a very beautiful section, namely congruency and similarity. Now I know that this topic rings a bell. I know it sounds familiar because we have dealt with this in grade 8 last year. We have gone through the cases and the conditions of congruency and similarity. In grade 9, we're going to go into a bit more depth, but don't worry, it's very exciting. So, what do we remember of last year, right? So, before we get into the topic, go into the chapter, there's some things we need to know and some things we need to understand before we can tackle the problems that comes with it. The first thing we need to remember is, as part of revision, we need to revise our properties of triangles. Very, very important. Because we know triangles are no longer just triangles we know as a shape anymore. It has very unique properties. And some of the very important properties for us to remember about triangles are, we know that the sum of the interior angles of any triangle adds up to what? 180 degrees. What else do we know? We know that the exterior angle or the outside angle of any triangle is equal to the sum of the two opposite interior angles. What else do we know? That's important. We need to understand the concept of the types of angles we have. So we have a scalene triangle, we have all the sides different. I have an isosceles triangle where I have two angles and two sides the same. And I also have an equilateral triangle, right, where all the sides and all the angles are equal. Very important properties to revise before we get going, right? And then, what makes up this part of congruency? It's the cases and the conditions. So we need to establish the conditions for congruency for congruent triangles. And we know there are four conditions, there are four cases. What are they? They are side, 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 angle, side, angle, angle, side, and then right angle, hypotenuse, side. So last year in grade 8, we have identified when shapes are congruent or when shapes are similar. In grade 9, we are going to prove them to be congruent and we're going to prove them to be similar to each other, right? So the four cases of congruency that we know. Similarity, what do we need to revise here? Revise proportion in triangles when the ratios are in equal proportions, and also we need to establish and investigate the conditions of similarity, right? What makes two triangles similar to each other? It's when I can prove all three sides equal to one another. All right, let's get into it. So again, we've learned this last year. Congruency, if two shapes are congruent, they are equal in size and in shape. This means that the corresponding sides and angles are equal. Very, very important because I've seen students mix this up. The symbol we use for congruency are three horizontal lines, and then vertical is for similarity. So just remember, for congruency, we have three lines as vertical. Please make a note of that. Write it, highlight it in your book. To prove two shapes to be congruent, we do not need to prove all the sides and all the angles, right? We compare the three elements of each shape using what? The conditions and the cases of congruency. So guess what? We're going to get straight into an example. But before we get there, I want to emphasize something, that the letters in triangle ABC and triangle DEF must correspond. And here's a note here, it says here that order matters. Why does order matter? Because if I take triangle ABC and I flip it onto triangle EFD, there are certain angles in this triangle and certain sides in this triangle that will correspond with this triangle over here. So if I flip this triangle onto this triangle, I'm sure all of you can see that that angle A will correspond with angle D. Angle B will correspond with angle E. It will sit on angle E, and then also angle C will basically sit on or correspond with angle F. And similarly, the sides, the side AC, the side FD, they will correspond with each other, and then also the side AB rather, and the side DE, they will correspond with each other, and then the side BC and the side EF, they will correspond with each other. Very important to note that. And here we all have it in writing. Okay, let's get into an example. So, example number 1, it's asking us, prove triangle ABC congruent to triangle DEF. Now remember, before I solve this problem, what must be in the top of my head? The 4 cases, the 4 conditions of congruency. Very, very important. Alright? So, how do I start off this? I start off by making reference to the triangles I'm working in. What are the names of them? Here it is, triangle ABC and triangle DEF. So, I start by saying, in triangle ABC and triangle DEF. What do I notice? What do I see that's the same? Come on guys, it's very simple. What do I see in this triangle? That is the same that I see in this triangle. So I could have put a number here, 5 centimeters and 5 centimeters. It's the same like having this line and this line. It's an indication that the sides are the same in length. So when I take a ruler and I measure the side, if I measure the side, they will be equal in length. So I can say that AB, the side AB, is equal to the side DE. That's what I've noticed. But what if my teachers taught me about geometry? Once I make a statement, yes, I must give a reason. After every statement, I must give a reason. So, what is my reason here? It's simple. It's given. It is given to me that AB and DE is equal. Right, let's see what else is given to us. It's given to us that the side AC and the side DF is equal. So I can say that AC is equal to DF. This is a C here. Oh, let me rather do that a bit neater. So I can say that AC is equal to DF. That is also given. And before I go to the last one, which I'm sure all of you can see, I want you to note something. What have I proven thus far? And sometimes it's helpful just to take your pencil in your exam, and once you've proven one side, you can put a little S there for side. I've just proven a side. And then AC and DF, that's also a side. It can't be an angle, so that's a side. So if you look now, what have I done? I have proven 2 sides equal already. So I just need one more side, or I need one more angle to meet one of the conditions of congruency, because I know we have side, 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 and we have side, angle, side. And obviously in this case, it will be a side. So I'm going to go, my third and last one is the side BC is equal to the side EF. That is also given. And boom, look what I've proven. I've just proven that 3 sides in 2 triangles are equal, and I've met one of the conditions or one of the cases of congruency that says side, side, side. I've proven 3 sides equal, and I can conclude, not I can, I should, I must conclude now. In conclusion, right, I can say, therefore, triangle ABC, therefore, triangle ABC is congruent. Remember the 3 horizontal lines to triangle what? Remember the order matters. If I take this triangle and I put it on here, which angles or sides will correspond with each other? So ABC must be DEF. I'm not yet done. What condition or what case of congruency did I use? I used side, side, side. There we go. They have just proven now that triangle ABC is congruent to triangle DEF. Okay? Now, this is for side, side, side. So, while you're watching the live, you are most welcome to pause it, or you're most welcome to come back to the video after the live have ended, all right, to go through the solutions of what I've done for all 3 of the other cases. Time just won't allow us to go through an example of each one, but guess what? The modus operandi stays the same. We look at the triangles like this, and you can see there the solution tells us that here we have a side, here we have another side, and here we have an angle. So it's obviously side, angle, side. I did the same thing. I said in triangle ABC and triangle DEF. What do I notice? I notice 2 equal sides and 1 equal angle. That is why I said therefore triangle ABC is congruent to triangle DEF. What case have I met? Side, angle, side. All right? So they have done one for angle side, they have done one for right angle hypotenuse side. Just to note here, we can see here, we have a right angle, 90 degrees, all right? So the angle C is equal to angle F, which is right angle. And with a right angle in a triangle comes what? An hypotenuse, right? So AB and DF, sorry, AB and DE is the hypotenuse. And then my last side that's equal, it's the side BC and the side EF that's given. That is how we prove two triangles to be congruent. We state what we see in the two triangles and we conclude by saying, therefore, triangle, whatever the name is congruent to whatever the name of the other one is, given that the order here matters. And then lastly, we need to state which case of congruency we have used. All right? So we have an activity lined up for us, right? So we have 4 triangles, or rather 8 in total, 4 different activities that we need to work through. So I'm going to tackle that after the break. Thank you. Welcome back, grade 9s. So I'm sure we have congruency buzzing in our minds, all right? And I've left you with a little exercise to do while I was away in the ad. Now, obviously, time won't allow us to go through each and every question in this activity, but I'm going to select 2 to do with you, right? And hopefully it just boosts our understanding of this, all right? So if we look at the first example, it was very, very similar or even identical to the very first example I've done with you. So I'm not going to do that one with you. I want to do number 2 with you. I want to do this one with you over here, all right? Now, I want you to note the following. We need to, it's asking us the question, prove that the angle WXY, here it is, WXY, is what? Congruent to triangle ZXY, to triangle ZXY. Now remember, when I'm proving congruency, I need to think of these 4 cases. I don't need to memorize the triangle and think about it. No, I just go with the flow. I see what is given to me, right? So I'm busy with number 2 now. Let's see. What did I say? How do we start off? We start off by naming our triangles. Which triangles are we actually working in? So I will say in triangle WXY, in triangle W, let me make the W a bit neater, in triangle WXY and triangle ZXY and triangle ZXY. Let's see what we notice. Let's see what is the same in these 2 triangles, right? So let's see what we notice. So in the 2 triangles, I see that the side WY and the side YZ, they are equal, indicated by 1 line in both triangles. So I can say that WY, the side over here in this triangle, is equal to the side YZ in my second triangle. And that is given. And that is a side, all right? What else do I notice? I can hear you guys screaming through the screen that WX, the side WX is equal to the side XZ, and that is also given to me. Now, I'm missing one more. But now I don't see another side being indicated by 2 lines or 3 lines or 4 lines. So which side can it be? So I want you guys to understand something. What happens if I take these 2 triangles and I separate them? If I take them apart and I have two triangles, WXY and then YZX. What will I notice? I will notice that it will share a common side. Both triangles will have the side XY in there, isn't it? So obviously, if these two triangles are sharing a common side, it means that the length of that side must be the same in the two triangles. So I can therefore conclude that I can say XW, or XY rather, is equal to the side XY. XY equals XY, right? And what's my reason here? I can say it is the common side, right? It is the common side. And what advice did I give you? When we started off, I said, take your pencil and just put there, I've used the side, I've used the side, I've used the side, right? And now I can conclude by saying, therefore. So therefore, triangle. So let's go. So we're going to go WYX. Or we can even go X, Y, W. It really doesn't matter as long as you follow the same order. But I want to show you something now. I'm going to go W, Y, and then X. So I'm going to go W, or rather W, W, Y, X is congruent to triangle. So I went, look here. Easy way to remember this, instead of thinking about that long slide with all the sides. So WYX, so I passed one line, right, and I went to the long part. So I pass one line and I go to the long part. What will this be? ZYX. It will be ZYX. Do not forget which condition or case you used. We used side, side, side. There we go. All right, we've just proven these two triangles to be congruent. Without me having to go through the solutions, I hope here you are shouting to me, here I have two sides and an included angle. So I have side, angle, side. I'm going to use here, what will I use by this one? When you have time to do it on your own, it's very simple. I see a right angle triangle. I know I'm going to use the fourth condition of congruency, which is right angle, hypotenuse, and then side. Okay? I hope that made sense and I hope that you understood it. All right? Let's move on to the next part of this that talks about similarity, right? So again, we've learned in grade 8 last year that similarity is not exactly the same as congruency. Congruency is when I have two shapes that are the same in size and in shape, but two or more shapes are similar if they have the same shape. So the shape is the same, but they have different sizes. The symbol used for similarity are three lines that are vertical. Right, so I have three vertical lines to symbolize the shapes to be similar to each other. And here we have a perfect representation of what two similar shapes look like. They are similar, the shape is the same, but the sizes are different. Hence why they are similar. All right, again, what are the two cases for similarity? We have worked through it in the beginning. We said that if I can prove that all three of the angles are the same, then the triangle is what? Similar. So I have angle, 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 or if the corresponding sides are in the same proportion, the corresponding sides are proportional, corresponding sides in the same ratio. It's all the same thing. And again, take note of this slide that talks about the order that matters, because again, if I take this triangle and I flip it onto this triangle over here, there are certain sides that correspond with certain sides, and there are certain angles which corresponds with certain angles. I want to point out something over here. I want you to see, if we look at angle A, here's angle A, it has three lines, right? So opposite angle A, I have this side over here, BC. What angle corresponds with angle A here? It will be angle D, isn't it so? And it means that obviously the side opposite angle D is the side FE. So then I can conclude that BC over here, BC, would be in the proportion with what? With EF, all right? So to simplify that even further, if you look at AB over DE, this is working with the concept of corresponding sides in proportion. If I take this triangle and I flip it onto this triangle. But a very easy way to remember that, girls and boys, you can see here they're asking us to say, to prove triangle ABC similar, this should be or congruent, well, this should be similar over here, DEF, What is an easy way to remember this? We take the first two letters, so it's AB, over the first two letters over here, which is DE. Then we say is equal to the last two letters here, it's BC, over the last two letters here is what? EF. Is equal to, we take the first and the last letter in the first triangle, which is AC, and we take the first and the last letter in the second triangle, which is what? DF. And this over here is just a summary of what I have told you about flipping the one triangle onto the other and looking at the sides that are in proportion. All right, so just to avoid any confusion, right? We don't have congruency here. This is congruency. Let me rather do this. So that is what? Similar, right? So if I need to prove similarity over here, remember, I just gave you a hack, a shortcut. Take the first two over the first two. Is equal to, take the second two over the second two, and take the first and the last over the first and the last. Right, let's get into it. So look what it says. It says there are two ways we can prove the two triangles are what? Similar to each other. We can prove it using, or stating rather, that all three of the angles rather, are equal, or the corresponding sides are in proportion. And this lovely example I chose over here, it covers both. All right, so I'm going to show you how we're proving these two triangles over here similar to each other using the concept of all three angles equal to each other. So we can say in triangle ABC and triangle PQR, what do we notice? Angle A equals angle P, which is 70 degrees, that's given to us. We notice angle B and angle Q, that is also equal. And then I have a third angle, which is angle C and angle R, both 30 degrees. And once I have proven that all three angles are equal, I can then deduce, I can make a deduction that triangle ABC, or therefore triangle ABC, is indeed, sorry, here's another typo over here. This should actually be similar. Please correct that. This should be similar, right? Because what I have there is congruent. So triangle ABC is similar to triangle PQR. Please take note of the order. I went A, B, C. So I went from 70 to 80 to 30. So here I must go from 70 to 80 to 30. And once I've done that part, I must give my reason. What did I use? I used the concept of angle, angle, angle. Okay? Right, hope that made sense. Now, using the same example, there's another way we can prove it, right? And sometimes in the exam, they will only give us the angle, the angles, or they will only give us the sides. Sometimes they will leave out one angle. But what do we know? We know if two angles in two triangles are the same, by default, the third angle should be equal. Why? Properties of your triangles, right? The sum of the interior angles of a triangle should add up to 180 degrees, right? Now look at this side. Look at this slide over here. I want you to notice something. Look, prove triangle ABC is similar to PQR. And if you can hack this little trick that I've showed you, you will not go wrong, girls and boys. What did I say? Let's say we weren't given the angles and only the sides. Another way we can prove it, besides using the angles, we can use the sides as well, right? So look here, what did I say? Take the first two and put it over the first two. There we go. Is equal to, take the second two, which is BC, over the second two, which is QR. Take the first and the last, which is AC, and put it over the first and the last, which is what? PR. What do I do now? I do substitution. Substitute means just put something in place of. All right? So in place of AB, it's simple. I have 4. In place of QR, I have 3. In place of PR, I have 4. I just substitute all my numbers. And guess what? When we simplify all those numbers, we get 2, 2, 2. And we see so beautifully that the ratio sides are in proportion, right? The corresponding sides are in proportion. So I can make a conclusion by saying, therefore, triangle ABC is indeed similar. This should be similar over here, is similar to triangle PQR. And I stated my reason. I can't say angle, angle, angle here because I've used the sides to prove that it is similar. Okay, now I want to go into a problem solving question right before we end off. And if we look at this particular problem, look what the question is asking us. The question is asking us, it says the AD, the side AD, and the side BC intersect at the point E, with AB parallel to CD. Very, very important. Parallel, because when I see the word parallel, or when I see these two arrows parallel, then automatically three things come to my mind which I can use in geometry. But let's first see what the question is asking us. It is asking us, by number one, to prove triangle ABE, prove this triangle, prove this triangle similar to this triangle over here. So either we're going to use the sides or the angles. I don't have any sides given to me, so how can I use sides? But neither do I have angles. So now I'm stuck. But something else is given to me here in the diagram. Yes, these two arrows are given to me here. And we know when two lines intersect, right? And we have the two sides that are parallel, which is split by its transversal. What happens? We have three beautiful mathematical relationships forming in the name of corresponding, co-interior, and alternate angles. And obviously, in this case, what are we going to use? Will it be co-interior? No, it can't be co-interior. Will it be corresponding? No, not corresponding. What will it be? Yes, alternate. And we usually say with alternate angles, we look at the Z shape or the N shape. So this angle over here will alternate with this angle over here. So angle A is equal to angle D. And then angle B is equal to angle C. Isn't it so? Yes. Now, quickly, let's go through the solutions. So, what do I notice? So, I first notice, I say, in triangle ABE, and triangle DCE. Remember, I'm not doing congruency, I'm doing similarity. I can't use the sides, so I'm going to use the angles, right? So, what do I know? I know that angle A is equal to angle D. Why? Alternate angles, right? I have two angles, right, that are equal. So I can say that angle A is equal to angle D. Is my reason here given? No, it's not given. It wasn't given to me that it's equal. I needed to use something of geometry to prove they are equal. What have I used? I've used alternate angles. But remember, when I state what I'm using, I must say why. What makes these two angles here alternate? It's the fact that this line AB, it's the fact that that line AB is parallel to this line CD over here. There we go, one angle done. Another one, I know that this angle B, is equal to angle C, and that's also because of alternate angles, for the very same reason that AB is parallel to CD. And then lastly, now by default already, the third angle must be equal, because sum of angles in a triangle adds up to 180. But just to show you what is the third angle here that's equal, I can see you guys shouting out, it must be these two angles over here. Why? We know when two lines intersect each other, the vertically opposite angles are equal. So how do I name this? I can't say angle E, because angle E is made up of two angles, right? I have an angle E1 and an angle E2. So I must say here that angle E1 is equal to angle E2. What's my reason there? It is vertically opposite. And there I've just proven that the two triangles are what now? Similar to each other. So I go, therefore, I look at my order, triangle AEB, therefore, triangle ABE. Take note of my order. I say similar to triangle. So I went ABE. You can start off anywhere over here, but the way in which you state it here is important. So I went ABE, so I went from the circle to the X to the 1. So I must go from the circle to the X to the 2. So it's DCE. So it's DCE. And whatever I use there, I've used angle, angle, angle. All right? They have just proven that the two triangles are what? similar to each other. I'm going to leave you with some homework before we wrap up. And the homework I'm leaving you with is to calculate the length of ED and the length of EB. Now, they're asking us the length of missing sides. So just to quickly wrap up over there, if we know that AB is 4 units and we know that AE is 3 units, it's given to us that CD is 8 units. It's given to us that CE, where is CE? Here CE is 4 units. Calculate ED and EB. And whenever you need to calculate the length of a side, what do you need to use? Just set up your equation that I have given you before. There's that easy hack trick that I've shown you. So remember, you just take the first 2 letters, which is AB, over the first 2 letters, which is CD, and you make it equal to the second 2, which is BE, over the second 2, which is CE, and you make it equal to the first and the last, which is AE, over the first and the last, which is DE. Once you made that statement, you put here in brackets, what give me the right to say this? Because I have just proven now that triangle ABE, I've proven that triangle ABE is similar to triangle DCE. All I do is now, I just need to substitute my points. Maybe I can quickly do that with you, right? So AB is 4 units over what is CD, it is 8, is equal to what is BE. I don't know what BE is, so I'm going to leave it, over what is CE. CE is 4, is equal to what is AE. AE is 3, over what is DE. DE, I don't know. So guys, what they're asking us for? They're asking us for ED. Where's ED? Here it is. ED, DE, the same thing. Look what I do very quickly. This can be simplified to a half. If I want to solve for DE, I take this fraction and I put it here. And what can I do to get DE on its own? I can find the LCD, or I can just cross multiply. I'm going to choose the easy route. I'm going to cross multiply. So DE times 1 is just DE. 2 multiplied by 3 is just 6 units. There I have the length of DE. And then lastly, they're asking us for EB. EB is over 4. I'm going to use the same fraction, which is a half. Why? Because the ratios are in equal proportions. So if I cross multiply 2 multiplied by EB, I get 2EB. If I cross multiply 4 with 1, I get 4. How do I get EB on its own? I divide, of course. I divide by 2, I divide by 2. The 2's divide, so EB will be 2 units. All right, there we go. That is how you solve an unknown in any problem when it comes to similar triangles. Just set up your equation using the trick I've given you and you won't go wrong. Grade 9s, I hope you have enjoyed the lesson. I hope that you understand congruency and similarity. Do not forget to like and subscribe to Masky TV, or leave us a message on the WhatsApp chat with the number 072 9103 88, and I'll see you again. Thank you. Goodbye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.